Thank you for joining. My name is Yushen and I will be your moderator today. Today's session is titled Railway Domain Session 2, Our Path to Climate Neutral Rail Infrastructure. Before I hand over to the speakers, I will remind you buildingSMART is committed to ensure that participation in the development of standard is unrestricted and the process of their adoption is transparent, and the standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take notes to our antitrust code of conduct. Now I would like to hand over to Jahim.
Thank you very much. A very warm welcome, everybody here in the room in Berlin. I'm very grateful that we can speak today about our path to climate neutral rail infrastructure. Also, a very warm welcome to everybody in the stream and the virtual room. I'm very happy that you're with us. My name is Jonathan. I'm working for the Deutsche Bahn, Europe's largest infrastructure manager, and I want to showcase you today the path that Deutsche Bahn is going to meet the climate neutrality target of the European Union and Germany. And I'm here with 3 colleagues, and I invite you to present yourself and talk to the group what you're speaking about.
Yes, good afternoon, everyone. I'm David Görner from the Swiss Federal Railways, and today I try to bridge topics of digital product passport, eco-design regulation, and BIM in our proof of concept we do at SBB.
All right, it's confusing with all the microphones. Hello everyone. So my name is Manuel Kretlow. I'm working for DB Engineering and Consulting, and I'm also very glad that everyone found their way here today because the German railway wasn't really on point the last days. I don't know whether someone came from Hamburg all the way, so it took me 7 hours to get here. Thanks for letting us present as well some insights from our company, especially regarding the life cycle assessment based on BIM models. And I brought my colleague Fernanda.
Hello, I'm Maria Fernanda. I'm also from Deutsche Bahn Engineering and Consulting, and we will be presenting BIM-based model life cycle assessment today.
Perfect. Thank you very much. Afterwards, we have the 3 presentations that you also can see here on the slides. And afterwards, we want to get to know you. What is your point of view on these topics? We want to see if you have already some challenges in your companies, what you're bringing with you here to this room. And we are very looking forward to the discussion afterwards. Our path to climate neutral rail infrastructure. Maybe it's a bit unusual question for a digitization conference or here for this buildingSMART summit. But we will show you how the connection between digitalization, sustainability, and rail infrastructure is. As you all know in this room, climate change challenges all of us here in the room, all of our companies and our business models. We have different targets here in the EU, in the different countries we are working in, and today it's more about the rail infrastructure. Railway companies around the world, and especially in the EU, are presenting themselves or are advertising themselves and their business models with their low impact on climate. We are proud that we are more part of the solution than that we are a problem. But when we are looking on the railway infrastructure, we can't hold this point. Railway infrastructure, as you probably all know, consists mostly out of concrete and steel, and that's probably the most harmful you can do for the environment. So in this case, we are not part of the solution, but we are the problem. And we will showcase you how we are working on this challenge and how we work on railway infrastructure to make it more sustainable. It's not only a problem of our advertising that we are currently are running. It's also the second problem. What we have to talk about is the mode of transportation. When we compare ourselves to different types of transportation, like the airplanes or the car transportation, we are the most sustainable one. But it's mostly the case because of the rate of electrification of our transport. But in the next years, you all can read the news, especially when we talk about car transportation, they will also electrify their mode of transportation. And when we assume that the electrification on the streets is probably around 2030 or 20, when we're looking on 2030 or 2035, the rail infrastructure is more coming into the whole picture. Railway infrastructure is more or is mostly based on concrete and steel, and it's more intense than for the roads. Because we have higher loads that we have to transport, we have lower gradients, we are faster, so it's a lot about concrete and steel. So our competitive advantage against the other modes of transport is going to be diminished. And this advantage that we have today is our most important point to get our financing by our owners. So we have to talk about what we can change in our infrastructure in the next years. And it's always good when you make an analysis to know the status quo and to look maybe a bit into the back to know what is the problem and how big is the problem. But the more important point is always to look into the future. And we see, especially in Germany, that in the next years, a lot of money is going into the railroad infrastructure. And you can just do a small correlation and also a causal claim. Money into railroad infrastructure is money into steel and concrete. And it's always getting higher emissions in the long run. So that's pretty basically very negative for our advertising claim that we are the solution in the future. And what we see is that it's not only important to look into the future and say how big the problem is. The next step is always to look what you can do in the future to tackle this challenge. So now it's time for the funny picture. We spoke a lot with our main suppliers, with our building companies, and to ask them what can they do to work on the problem of emissions in the railroad sector. And we came up with 6 levers to tackle this challenge. The first is always the planning. It's about the materials. We have to focus on the reuse of materials. The logistics is always very important for building infrastructure, and we have to talk about the stations and the maintenance. These are the 6 main levers to decarbonize the railroad infrastructure and to still focus our green claim. What is behind these levers? When we start, it's always about the planning. I think you all know that the great how you can change a planning is always the highest in the first sections of a planning phase. It's always in planning phase 1 and 2. You have the most, or you can have the most impact on the infrastructure. So it's about optimizing the construction method, the structure or the geometry of a building or a bridge. When we talk about materials, I already said the infrastructure or the railroad infrastructure is mainly about concrete and steel. It's also about ballast. Ballast is not a very carbon intense material, but it's a lot of load or mass. So we also have to talk about these materials. We also have to talk about the reuse of these materials. So at Deutsche Bahn, we already are pretty okayish when we talk about the reuse of sleepers, of rail steel, and of ballast. We have different targets for these materials, but we need to get more into these topics, especially in the next years when we start, or if we start our huge refurbishment program for our railroad infrastructure. We also have to talk about the logistics. It's mostly about alternative fuels for our machinery. And we also have to talk about the maintenance. So if we can extend the life cycle of our buildings, that's a very important point. But I think my colleagues will speak a lot more about these topics. Just short hint to the next two presentations. For us at Deutsche Bahn, we speak a lot about green BIM as our process to assess energy efficiency of our buildings and the sustainability of our infrastructure projects throughout their entire life cycle. And that's the part where my colleagues come into place. We need more data-driven or evidence-based insights into our buildings, into our bridges and tunnels to make good decisions. And that's what Fernanda and Markus will talk about.
Thank you very much, Jonathan, for this very insightful presentation. Now we understand our goals as company and where we want to head into sustainability matters. I would like to present a BIM base mold life cycle assessment, BIM for LCA, which is a tool that we have developed in the VE Engineering and Consulting Group. So I guess the first question you are having right now is what's actually a life cycle assessment, LCA? Well, basically, it's the evaluation of the environmental impact of infrastructure in its whole life cycle. So we take into account the materiality and also the energy flow of an infrastructure project. Of course, following the corresponding standards and norms, which gives us a framework to work with. I guess you're more familiarized with this type of analysis, but with the perspective of costs. So we evaluate, okay, how much is going to cost my project in the construction phase, how much I will need to pay for the operation and maintenance, and analyze this throughout the costs in euros, in dollars, in the currency you're working on. We do something similar, but with carbon CO2 equivalent emissions. And therefore, we can evaluate different designs and take good decisions based on the information. So if we have two designs, we are going to, of course, recommend the one which has the lowest carbon emissions. And now you're thinking probably, okay, but in your slides, you're saying me that you're preferring this, which has like the highest peak of emissions. But if you see here, the second design has two peaks in the maintenance. So if we evaluate the design in the whole life cycle, we can see that actually the second design has a higher level of emissions. That's why even if in the construction, the first design has more emission, in the overall life cycle, it has lower. So we will actually prefer that design. Okay, really nice, this idea, but where can I get this information? How can I calculate the CO2 equivalent? Well, then here we have a very important part, which is the EPD, the Environmental Product Declaration. This is the basis that allows us to calculate the emissions or the indicator that we are analyzing. These are stored. These EPDs have different indicators of a particular material, in this case, global warming potential, and we can get throughout the whole life cycle the different indicators value. So, for example, from A1 to A3, we have raw transportation to the manufacturer and manufacturing. Phase C3 will be reuse, C4 will be disposal, D will be recycling potential, and so on. Really nice. Now you have not spoke about anything about what we are here in the conference, Building Smart. Well, we spoke already a little bit about the environmental information, but there is a very important part, which is the information of our design. And here is where BIM comes on. And here I have pointed out three main topics that allows us to do a life cycle assessment. First one I have here pointed out, open BIM formats. Of course, we need the information of our infrastructure project. And how can we access to this information? We can access through the model integration throughout the IFC. Of course, we also need standardized environmental data formats so we can create processes. This can be, for example, storage in XML, but with standardization, so we can have a consistent life cycle information. Also, very important, we need to access to these EPD databases, which should be also reliable. In Germany, we have the EcoBaudat, which has a considerable number of EPDs, which we also use in the evaluation of our projects. So to create a LCA, a lifecycle assessment, and to reach this full potential, we need to integrate the data and to make it also interoperable. If we have a centralized data management, we can connect the BIM information model also with the environmental data. In IFC 4.3, there's actually also the possibility. There is the PCIT environmental impact values, where you can see there the climate change, or I don't think you may read because it's quite small, but believe me, there's the information. But we think that the workflow that this offers, it's not so efficient. That's why we suggest a different approach, and we suggest BIM for LCA, which allows us with a very few numbers of LCA attributes to connect the object information to an external EPD database. So we are not getting the whole information of the EPD in the model or in the objects. Here I have an example to make it a little bit more clear. So if we have a BIM model, the first thing will be, okay, we have the object wall. Then throughout the BIM model, we can get the quantities. In this case, we have 129 cubic meters as volume. Then we go to our EPD source and we search for the material information. In this case, this is concrete C3545, and we can see that the globe, which is 1 cubic meter, has a global warming potential of 244 kilograms of CO2. So as we are working also with the same units, in this case, in this example, it's quite easy. We do the corresponding multiplication, and then we get for that object the amount of CO2 equivalent emissions. This is a very general example, so we can understand a little bit how this works. But this is the workflow that we are using at the moment, which is a full base model approach. We start up with the discipline models, the different discipline model. Then we create the coordination model, the federated coordination model. And from this model, we only use some few LCA attributes. And then we get the quantities based on the BIM model. And we transpose these quantities to our own LCA engine that we have created. And this connects this information with external information through APIs, so application programming interfaces, to an external APD data. This can be the EcoBauDAT here in Germany, but we can also use different sources of information. And then we do the right calculations in this engine. And then we return the results, which can be also exported and further analyzed. But also, we don't want to stay there. We are also working on BIM model, so we must use the chance also to visualize the results in the coordination model, which we also do. This is quite dynamic and flexible, so we can change, and if there's a small change in the EPD database, we don't need to change the whole information in the objects. We just updated these connections. And this allowed us to make a faster iteration process with the design. But afterwards, we are going to have like a live demonstration. So if you're interested in, my colleague is going to explain that. And you can approach to us and we can show you different models that we have done the analysis, the LCA analysis. And we can see the different settings that we have used and the LCA attributes that I have mentioned here. So here also we have a project which was administrative building of a ICE, the trains depot for Deutsche Bahn Fernverkehr. And we had two designs, and with the tool we could also visualize how were the emissions of the two designs. Also, we have here a better understanding of the emissions in the different life cycle phases. And therefore, we can take more informed decisions based on data from the BIM model and also from the environmental information. Also, we can also very nicely, we can visualize the results by classification. So we can see, okay, which parts and which objects of our model are having a higher impact, environmental impact. Here we have, for example, interior walls, external walls, stairs, slabs, and so other. We can also see it quite nice in the model, directly in the model. And in Deutsche Bahn, of course, we have also many large-scale projects. This was an example of a railway tunnel for DB Infrago, where we had more than 80 IVC models, but with our workflow, it was actually quite nice to work with because we're working with the federated coordination model. And also a very important topic is usually people think, okay, the emissions are like more focused on the manufacturing part. But if you see here in this example, we had the information because we did the LCA. We also knew that 34% of the total emissions came from installation and assembly, which is not a small number. And without this, we will have not known that. So there is a not small, there is a challenge in the railway domain with the life cycle analysis assessment, and it's that EPDs are quite difficult to be found for such a specific domain. But we also have an opportunity because we have a very high level of standardization in the rail domain, which allows us also to automate our processes. So in DB engineering and consulting, we have our BIM standards, which is basically an object library. And in this object library, we have also unified a level of information of our objects. So we can create these few with these databases that maps the objects, the standardized material, sorry, with the right EPDs. So if we have a model that has standardized objects, we can automate this process. And even if we have objects that are not standardized, but have standardized materials, we can also standardize these parts. Okay, and standardization doesn't only help us to automate the whole process, but also gives us the opportunity to use GIS data and to use statistical analysis to be able to do and to perform a life cycle assessment in very early stages of design. Which is a huge advantage. Here I have a map where you can see visually the colors of emissions also and spot the highest points, and also analyze further with other type of diagrams and information. So yeah, this is the current state. But now I will pass the word for my colleague David, who will explain a little bit more what they are doing in SBB. Thank you.
Thank you very much. Okay. Perfect. Yeah, so also welcome from my side. We have heard first on a very strategic level, then we went to project level. Now I take you on a journey on element level. We're talking about rail tracks. Because at SBB, we're a railway infrastructure. We are dealing also with sustainability and circularity. However, we try to do it in line with, we heard it yesterday, the European regulations that are implementing DPPs, and we really try to use this rolling train and take most advantage we can from the standardization processes as well. But before I dive into my presentation, many of the concepts I'm going to touch on are also nicely summarized in this white paper by buildingSMART Switzerland, where we could co-create a strategy for the Swiss market, but it was also translated in English, so it is also of relevance for other chapters. So feel free to scan the QR code or afterwards come to me and I will send it to you manually. Doesn't work? Okay. Let's discuss it afterwards. So great. Putting some context. So there is something called greenhouse gas protocol, and it's actually a very powerful protocol to explain CO2 emissions. It divides them into 3 scopes. Scope 1, direct emissions. We are in charge. It comes from maintenance of railway infrastructure. Scope 2, indirect emissions, but we have an influence on when we purchase energy. And then it's scope 3, it's our supply chain. And you see it's by far the largest chunk. So this is our material flow analysis by SBB. These are real data collected in 2023, but it hasn't shifted that much since then. And if we look into our supply chain, we have created further categories, and the biggest category, almost 40% steel. Which is not that surprising. Again, we're a railway company, so it comes from rail tracks. And it's not only the load and the weight of the material, it's also 630 kilometers of rail tracks that get replaced every year. And of those 630 kilometers, 10 kilometers on average, we reuse in other parts. And this is not because the rail tracks don't meet some standardized quality levels anymore. It's often just a simple fact that end of life, we don't keep track of them, and it's just way easier to recycle them than to reuse them. So what's the goal? The goal is we want to take decisions on an informed basis, and for this we need data. Because if we don't have data, rail A and rail track B are exactly the same. We have differences like price, quality, safety, but we were already aware of them before. But now with the DPP, the regulation also Lars Fredlund was yesterday referring to, we have environmental data, essential characteristics about the products placed in the European market. And we need those information so we can prove that rail track A is not equal to rail track B. So data is key. And not only the data, it has to be trustworthy. So that's why we have regulation. That's why we have standardization. For the last 1.5 years, we have been working in CEN JTC 24 to standardize the digital product passport standard. Revision of the draft standard was just finished. And we heard it also, I think, today in the GS1 input that Q1 next year, the standard will be published in the official journal. So we're not talking about something that might come in the future. It's already here. So the trustworthiness of the data, very important, because if we don't have it, we depend on self-declarations. We depend on average values from databases. So we, again, have to treat each product from the same product group exactly the same because we apply an average value. We are not aware of the ingredients relevant for circularity. So a lot of use cases that require this information are impossible. And last but not least, it takes a huge effort in handing over this product information across the life cycle of product across systems. So that's why DPP is here. DPP is the tool we can use. We don't have to, but we can use, and which delivers a solid data foundation that would enable many use cases touching on sustainability and circularity. Let's have a look at the process. I will start on the left side. That's what I've already touched upon, standardization. It's already here. Regulations are here. We know there's going to be an EU data dictionary. There's going to be product data template per harmonized product standard. So this is something we don't need to care about because it will come. What's important is what's coming then. Not only manufacturers will use this product data template to provide their product information in a machine-readable format. It's also ERP system that can prepare using the same product data template to make sure that once the product is delivered, it can seamlessly integrate it in inventory systems. On the bottom line, we have design. We already are aware of the concept of data dictionary using product data templates. So we can also use the same product template in design phase. And this is what we yesterday heard many times. It's the same language. It's the same language that we need to speak that would enable us to make informed decisions. And then last but not least, on the right side, once we have the same structured data in our ERP systems, where we maybe inventory system, where we're talking about the physical product, and we have the same structured information in our BIM models, then we will be able to connect them and to know where what product is located. So end of life, it doesn't happen that we lose almost 620 kilometers of rail track per year, but maybe we can save a bit more and reuse a bit more. So I quickly go through all the three processes in detail, but I'm not gonna spend too much time because there are, in the product domain, there are many other sessions going way more deeper into it. But what I wanted to show here is this product data template used by the manufacturer has the integrated environmental product declaration that we just heard of. And here we're not talking about general EPDs. We're also not talking about manufacturer-specific EPDs. We're talking about product level EPDs. So it's not every instance, but batch level. And this is very important because this reliability, this trustworthiness of data will be very crucial if we take decision on which product to buy and don't want to be solely dependent on a price criteria, but maybe also on a sustainability related criteria. So this is how manufacturers get their product data templates, create their product data sheet, and attach it via a data carrier, could be a barcode, could be a QR code, could be RDF, whatever. There's gonna be some freedom for manufacturers to choose what suits best their product. Then design stage. Here, same process. We chose the BSDD for our proof of concept because it's very familiar in the community here, but it could be any data dictionary. There are gonna be many new data dictionary popping up apart from the EU data dictionary. But that is where we can interact with standardization when we have trustworthy, structured product data templates by CEN standardization committees. So we know when we go with this product data template, we have an assurance that in the end we can match it with the real information we get from the manufacturer. And in our company, we call this logical object. You can call it digital twin. It's just a digital representation of the rail track that at one point in time in the future will be used on the construction site. On the other side, we have logistics, the ERP systems that use the same product data template to prepare inventory systems. So once this product is delivered, we can scan the DPP and we can have this information flow, this automated information flow, because on an attribute level, on a data protocol level, we have a common standard. In our proof of concept, we have this additional difficulty that products like rail tracks get delivered in 108 meters, and we have our storage capacity in 12-meter coupons. So we are going here with some GS1 solution, but it can be any other solution where we have to cut rail tracks into these coupons, 12 meters, and we add additional identifiers. But all identifiers can be traced back to the original DPP, because that's important. In the end, when we have end of life of a product, we want to know what was the origin DPP, so we know exactly what was the environmental footprint. So now where the matching happens on the construction side, we were talking about this logical object using the same product data templates. We're having the physical object in form of the product that's delivered by the manufacturer. And we can match them on the construction side by using a product identifier, just as the GTIN. This process, it is still some manual work involved. Like welding of rail tracks, someone has to scan which identified product goes to which place in the BIM model, but it can be integrated in existing processes like the documentation of welding, which is already part at the Swiss Federal Railways anyway. And if we look, it has been discussed in the session before where we were touching very quickly on the semantic web. The DPP will also be available in an RDF format. So we will have linked data principles. So in the end, it's not only the product identifier that we can store in a BIM model in an ERP system. We can store an URI that will lead to this EU registry where we can retrieve values we're looking for. And this opens again new use cases. And now just to sum up, one use case I would like to present to you because it's actually very powerful and very simple to implement. So if you have already collected some EPDs from manufacturers, you can use the same way as I just did. You can use the values from the different EPDs just for the product of a rail track. And you will see that sometimes environmental emissions are 3 times as high for the same product, just because maybe the manufacturer invested in some decarbonization of manufacturing processes. And currently, we can't consider that criteria because we depend on averaged environmental product declarations. And we have a spend-based approach where we're just gonna take the cheapest offer, because we would also have to compensate emissions depending on the price. So with DPP, we can account for the effective emission on product level, and it will be a new criteria that we can take into consideration to take informed decision in decarbonization of our railway infrastructure. Yes, so that would be it from my side. And I hand over to Jonathan, right?
Perfect. Thank you very much, David. So we are now at the end of our presentations. Do you have any questions concerning? Yeah, go ahead.
I'm sorry, I promised Candy to not ask any like very mean questions. I think it's very impressive what you did. There's one caveat: alternative costs, and I think it's a conflict of objectives. So if you're just running your project against the LCA output and you think its carbon emission is very low, you might miss the point that you're delivering too late because you're waiting for an LCA low product, and you have downtime in the railway network, and people switch to their cars. And so that's the alternative cost. So you should measure not only the production cost and maintenance cost, but also the opportunity cost that are when the railway network is down, people are shifting towards their cars and the carbon emission goes up again. So that could be a false positive what you're creating here. That's one thing. And the other thing is more political. Another huge lever is make the railway network performant, robust, in a way that you have a lot of uptime, and make traveling with the railway so attractive that people don't pick up their cars. In my opinion, the effect on the carbon emission will be way bigger than what you're saying. Last point, the curve that you were showing about the construction emissions and then those two kings, is that taken from normal building design or building construction life cycle, or was it specially tailored around transportation projects? So 2 comments and 1 question.
So thank you for the question. Maybe one thing regarding the decisions in a project. I think it's not about like yesterday we decided by costs, now we decide by carbon. I think that's not the purpose of it. I think it's rather an additional criterion that we want to add to the like decision matrix to decide. And the last, I forgot the last point.
The cost curve, like the decision.
Yes, of course. Thank you so much. I had a short blackout there. So the cost or the graph was actually just like a SketchUp. So it's not really based on like scientific evident data.
Okay, so where is it based upon what?
So,
like the,
no, it's
like the curve and the 2 kings. Where is
that was
from?
just like to sketch up how emissions could look like, but it's not like evidently
You
on.
made this up. So
yeah, it's like
there's no data behind that curve that you were showing.
No, that the first one it was just like just to sketch up to
Okay.
to
Got
show.
it. Okay, good point. Yeah, maybe the decision matrix would be very interesting. How you measure object against the objectives, and how much LCA comes into play with all the others. Because I think it's a typical, let's say, conflict of objectives and goals that you're having at this point.
Yeah, I think like the one project that my colleague showed with the administrative building. If you look onto the results, I mean, obviously we didn't decide by that we have that one preferred option and the other one is not our preferred option, because it was just such a small difference. It's more like that was more like a pilot project to show, okay, we can technically do this kind of estimation. And we want to support the decision making by that.
I still think the lowest or the highest LCA effect will be robustness over 30 years and uptime for the network, not the construction cost. If the construction costs are equivalent to the carbon footprint, and is it McLeary curve, where like design is like 20% of the cost and maintenance operations is 80%, and if that correlates with the carbon emissions, I probably say over the 30 years you have to do something to lower those, not also in the construction phase.
Yeah, it's always interesting on like which scope you are doing the assessment, because obviously, like if we are looking into our BIM models, we can't really estimate the effect that is already done by.
It's more complex than everybody thinks, because you have to look holistically over the full carbon emissions over the life cycle and the alternative cost as well.
Yeah.
Thank you very much for the presentation. I think it was last year that I was looking for tools for LCA analysis for the infrastructure, and the only thing I was finding was only for the buildings, nothing for infrastructure. So I'm happy that it's coming up. But so about the quantity takeoffs, I was thinking, taking the example of the electricity discipline that has must, which is metal, and it has holes inside. Depending on the level of geometry, the quantity takeoff can be very, very different, like 50% off. How so? Are you taking the number of must and their type, or really what is the volume?
Thank you for your question. We are actually taking the volume from the models. That's why it's very important to have these designs in this BIM model and have the integration with the environmental data. And so we can have access to the volume, and also we need to make sure that the geometry represents the real geometry of the object, because sometimes it depends also in the design phase we are looking at. Some objects are not modeled as the original form. So yeah, this is a quality check that we also must do when we are performing LCA. Yeah.
Sorry. One addition to that, I think the good thing about the workflow is that you are very dynamic in it. So even if you are in a very like early design, in a conceptual design, or you're doing the assessment based on GIS data, then obviously you can't really get the right quantities from the model. So it's also possible to set up your own kind of material compositions. We can actually show you later in the hands-on if you want, if you're interested in it. It's very easily like done, so that it's like super dynamic.
One last question. Will the LCA part of the tender materials? Yeah. Will LCA, like for tender and submission, when we say the Deutsche Bahn makes an RFI, RFP, RFQ for a railway bridge, how much will that be take into the documents that people delivering an offer have to include LCA, and because then it becomes really serious in the game.
We are trying it. So we are in discussions with our owners that we can do it. Right now, we published our first pilot projects where we are where we do it, but it's not in our for all of our projects right now. So yeah, it's not mandatory right now.
Thank you. Just, Jonathan, you said it's not mandatory, but we also discussed the question, is it allowed already? Because to take it as an KPI for the variance comparison, in previous time it was not allowed to take LCA into account. I remember, if I remember right. Or I mean, tendering is one thing, but if you are allowed to use that KPI, it's another thing. It's a question: is it already allowed? Or
yeah, it is already allowed. It's just a topic of financing with our owners right now. Okay. So, but it is allowed to use. Yes. Yeah, I think so. Yeah.
So LCC we can find in our tendering documents already, but LCA is still missing. Yeah, it would be nice to find it. And another comment to your question is like, if you have quantities in a generic way in the early stage of design, it's one thing, but you also need generic EPD data. And if you have product data for final stage and detailed phase, that's nice and that's usual, but not for generic early phases. So we are missing the generic EPD data. And I think that should be also available by public, because it's a producer independent database and no one will do that apart of you or of the government. I don't know. Yeah.
So actually a very good point. And I think the main question we have to ask us is the comparability of the results, because everyone can do a life cycle assessment. We saw it's like a super easy calculation, but what's the result worth if we don't standardize the data? So I'm totally with you that we need like shared generic but also product EPDs.
It was said that a lot of railway objects or projects are standardized. So even though a lot of it can be very accurate from an early standpoint, even if we're using generic data, so the only thing we have is like where you have a company using carbon neutral cement, for example, for the concrete, and everybody else doesn't. That's where you have the differences. But if you look at it from an early phase, you shouldn't be using those low values anyway. So most likely you can go in and look at every, especially when we have the DPPs in place, you can probably take an average between those or eliminate those who are very low when you do a generic study in the early design phase because of this. I think that's also something to consider, because rails, 60 kilos rails are the same weight, depending if you are a little bit different depending on which type of 60 kilos rail you're using, but in general they're weighing the same per meter, so you know more or less how much steel they are used. It's just a process. So for a lot of, especially for track, a lot is very similar, and from the table diagram you showed, there's very little difference between three equipment to make climate or less carbon emission for them. I think that is also something to take into consideration.
Maybe if I just can add something about the generic data. I mean, one of my goals, because we have the summit in Berlin, was that someone from OpenLCA, they're also here in Berlin, would actually join the summit to show how they work in an open LCA community, because generic data is available. There are platforms for database exchanges, and usually on a national level, you copy the database provider you prefer. It could be EcoInvent, as the Swiss government does it, and then you add some country-specific add-ons, because maybe you're not agreeing with certain generic information, and you do your add-ons, and then you publish it on OpenLCA, where if we would work together, OpenLCA community, OpenBIM community, we could create interfaces, exactly. So this is a very valid question, because they are there, the generic data, but they're just not applicable and not comparable. Very important point. You need to stick to one database to be at least within the same rule set, but it's something we need to tackle, yeah, by also bringing both communities together. Yeah.
Okay. Also, there are three questions from the China State Railway. And first is, do you think of the plan or in the design phase? Do you think about the comprehensive hub for the station? Like, because there's not only the station building, but also maybe the subway and the bus station and something like this. So did you concern a comprehensive the hub for this in design phase? That's the first question. And for the second question, because we saw that you mentioned that you can calculate the based on the parameters, you can calculate the carbon the carbon amounts. And is that work for now? Like you can calculate the carbon directly based on the current standard and product, or you need to unify the different product and standard. Then you can to realize that function, like to calculate the carbons directly. And the third one is about the operation, like how to connect your life cycle to the operation, like how to realize some function for the operation, like the maintenance. Yeah, that's all questions.
So the first question, I with the bus station.
No. I mean, because for if we focus on the station, we not only are not only talking about the station building, but also maybe some hub or some connections with the airport, with the bus station, with the subway. So do you concern about all of this in the design phase for your life cycle?
Well, it depends on the project. So if we are, if they are, yeah, I think you can answer.
So to give you a very short answer right now, no, we don't. I mean, it's always a question how you set up the scope of your calculation. And
Yeah.
if you put it too wide, then you can't really assess it right now. It's like if you look only onto the infrastructure, then you need to compare it with different modes of transport. That's all. Like it will be possible, but of course you need to do assumptions, valid assumptions to do these comparisons. So right now we're focusing more on the project, try to set up the scope as good as we can, that it's a valid calculation that we do, and don't put the scope too much or too wide, because we then it will be really hard to get good results in the end.
Yes, because if in our opinions, we think that we can concern or we can do some research about the hub. I also say it's a hub. Like we can connect the station building with the other maybe function area. So it's a entire we call it station field. So so we can research this as the object to the life cycle.
Yeah, you have to do that in the beginning, really tell yourself, okay, what do I really want to do with this calculation? What am I comparing? Am I comparing, or do I just want to document? And then you really have to evaluate whether the scope you're setting and the objective you are putting yourself is valid, or whether it lacks somewhere.
Okay.
And I think we haven't not yet addressed the second question, sorry, about standardization and if we are already working on that. So yes, we are working on that. We have already, with different experts, structural experts, we have also done the corresponding materiality, because with the EPDs, we need to define also the composite for a particular material, and we have like specialists that have helped us to build this database where we have the connection between the objects, standardized objects, with the corresponding EPD.
Okay. And I think maybe one addition to that, I think that's where my colleague also said before, where the implementation in IFC is currently not sufficient in our eyes, because if EPDs change with the time, then you have wrong values, wrong indicators within your model. And so it's, from our point of view, it's not the solution to put every value in there, because right now the data is just not standardized enough, and it will always change. So and if you then rather do that in the background, linking the model object with a asset in your database, and then change the EPD data, then you will always get like new calculations, and which are then more on point.
Okay.
Thank you for presentation. I also have 3 questions. First one is that the method of calculating the emissions, is it a standard, or or it is particularly in this project? And the second one is that there are huge data connected to BIM, and how do we fill in the values of the parameters? And secondly, do you have further research on water pollution? Because I see it's all about carbon, some kind. So we focus on water pollution during building the tunnel. So have you further research on this? Okay.
So I'm going to answer the first question. We work on specific projects, and in terms of standardization, we have some projects where we have work on also, but it's never 100% standardized, of course. So we still need to make the assessment for all the objects that are specific for the project, and especially in large scale infrastructure. But if we have buildings, which we have also had as our projects, then it's usually more specific project life cycle analysis. And the second question, I don't recall, but
regarding the last question with the tunnel, it's actually nice that you asked before, because we will also be on the big tunnel conference in, I think it's in November in Hamburg. And we'll have a presentation about a similar topic, again, model-based lifecycle assessment, but particularly for tunnels, because tunnels are one of the major contributors in terms of emissions within the infrastructure area, because the construction, the way of constructing the tunnels is just super energy intense. And we also did some studies with partly based on models of from the design department, but also in deep exchange with the designers, because obviously we don't know exactly how the tunnel is designed, because we are not structural engineers, but we really sat together and talked through the objects, talked through the way of constructing tunnels, and really good got some really good quality results, which also are complying, or not, let's not say complying, but they are similar as the ones that come from scientific studies. So we did kind of a validation using that. So stay tuned for more. We will maybe see each other in Hamburg on the Stuva.
I believe it's the 24th, 25th of November, if I'm not incorrect.
Yeah,
something like
maybe,
this. End of
maybe
November.
better check it.
End of November, yeah.
So this was all about calculating, but if we go into topic of material, on how to change the material used to reduce actually the carbon emissions, I don't know if there are experts in the room that if the regulations and science allows changing the material, for example, using the reusable concrete or other combo of metal. I have no idea.
Go.
Yeah, I mean, generally, in the harmonized product standards, there are safety essential characteristics, and as long as they are met, there will be innovation and there will be new materials used. But there is nothing foreseen specifically, in this Green Deal regulation chain of regulations, with this regards. Just maybe one thing, that standards are way quicker published, because we had this issue of this vacuum where there were many innovations happening, but the standards weren't published as harmonized standards. That's also what this process should change. So in the future, we can expect a faster standardization process. And maybe that could answer your question, that if you have an innovative new product that's not covered by a harmonized standard, you have a higher chance to get harmonization done than you would have had maybe 20 years ago. Yeah.
Okay, I don't see any more questions in the room. Then we already heard about some hands-on insights into the tools. And I ask David, what did you prepare for our participants?
Yes, because there's a slight change. So with me, it's going to be hands-on, interactive workshop session, not too long, thinking about information flow of LCA-related information, not only within BIM tools, but like literally from logistics to reuse. Yeah.
And that's not the only offer we have for you.
Yeah, we are going to show the tool live here. We have 2 examples on my side. These are building and a depot, and also Manuel has in his laptop 2 examples of real projects of a tunnel and also a bridge. So we can see the LCA attributes and also the calculations done in the tool.
Perfect. So you can decide.
Okay.
Where you want to go. Yeah, pick your team.
We'll distribute a little bit in the room,
Yeah.
and then just
Yeah.
okay.
For online attendees, thank you for attending today, and we looking forward to seeing you in other sessions of the summit. Thank you. Bye.